So we're going to choose today 90 degrees because that's a degree that we're all pretty familiar with. A 90-degree angle makes what? A right angle or a perfect L shape. Okay, so here's what we're going to do. We're going to rotate this point P 90 degrees. And the way we're going to do that is we're going to use a protractor. Okay, and if you don't know how to use a protractor, I'm going to show you right now. All protractors have a center. Most of mine have like this hole right here in the center. Okay, that hole should line up with this point O right here. Okay, and you can start it however you want, but then the line that I have highlighted in green, that should line up directly with the line that connects O to P here. Okay, so your protractor should look like this. Now, to go 90 degrees, obviously 90 is the big number right here. This is our 90 degrees, and we're going to take this and we want to go the exact distance. So right now, I just want you to make a little dotted line from 90 degrees because we're going to end up putting the point on this line somewhere. We just need to know the exact distance that we're going to put it. And there's two ways you can find the exact distance. You can either use the mirror and rotate it, or if you didn't have a mirror, how else could you find the exact distance? Does anyone know? Starts with a mesh and ends with a jur. Measure. Okay? So if you have one of the protractors with a ruler on it, you can measure the distance, the original distance. So mine is 3.5 centimeters. And then you want to measure it over here then, 3.5 centimeters, and line it up on the dotted line that you made. So my point is right here, and I'm going to make that a little bit bigger because that's going to be my rotated point. And if you start with point P, what is the new point going to be called? If your original is point P, what's your new point going to be called? P prime. Now, if you have a mirror, you could have also done it like this. Put the mirror on point O like this, all right? And then rotate it by looking through the glass. You can see your point P, and you just rotate it to the point where you can look through going, let's see, on mine I'm going to look through going this way, and I can see that where to put point P over here. Now I'm trying to show you both ways because obviously when you're in my class you can use a mirror, but if you're at home, chances are you don't just have a mirror just laying around. A mirror maybe, but not a mirror. Okay, so here's the point. And you don't have to be super accurate, but the idea is we went from here to here. How many degrees was that again? 90 degrees. And which direction is that? What do we call direction in rotations? It's not left and right anymore. Does anyone know what the directions are called? They start with a C. Clockwise and yes. Okay, so was that counterclockwise or clockwise? Counterclockwise, okay? And we abbreviate that CCW. So this is a counterclockwise rotation of 90 degrees. It's a little counterintuitive, right? Because you think like 90 degrees, automatically your brain wants to rotate what direction? Well, automatically, like when we are thinking of stuff, normally our brains want to rotate clockwise. Well, in math, when you're rotating a positive number here, so if you have a positive degree, you're going to always go counterclockwise. Now we're going to do the same thing at the bottom, and now that I showed you what to do, you tell me the difference here. So number 2 says, let there be a rotation of d degrees around center O. Let P be a point other than O. Select D so that D is less than 0. Find P prime using a transparency. Okay, so what is the only difference between what they're asking me to do in number 2 than number 1? What? Less than 0. So now let's choose negative 90 degrees. It says D is less than 0. If positive 90 degrees up here is right here, where's negative 90 degrees going to be? The other way, the exact amount, right? So do it the same way. With your protractor, though, now, you're going to go the other way with your protractor. So here we went this way. Down here, we're going to turn it and go this way now. So line up that middle circle with the dot. Okay, make sure it's right on the line. And then you're going to want to make a dotted line starting here at 90 so that you can either use your mirror or measure how far out you should be going. It doesn't bother me which way you do it. I'm just going to measure. So, again, let's look. My line here is 3.5 centimeters. So I'm going to measure 3.5 centimeters out to this line. Oops. And then I'm going to make my new point P, which is P prime now. Okay. And this then would be a negative 90 degree rotation. So this is called, what direction is this then? Clockwise? Nope, this one's clockwise. This one goes the same direction as a clock would go, so that's clockwise. And so the general idea here is clockwise gives you what kind of degrees? Positives or negatives? Yeah, so you use clockwise with negative degrees. Okay. So the whole main point of this first page is the direction and whether it's a positive or negative degree. Okay. And actually, that's the whole main point of the first 3 pages. I just condensed it into one for the sake of our lesson today. So we're, once we have this, does everyone have this?
Yes.
Okay. We are actually going to skip a few pages now, and the last thing, or the next thing we're going to do is on page 21. We're going to go all the way to number 8 now. Okay, number 8. Right away, what's different about, before we even read anything or do anything, what's different about number 8 than 1 and 2? Doesn't have a point. We're not using a dot this time. We're using a straight line. Okay? So it says let L be a line and O be a center of rotation, just like before, but we're going to use line. Let there be a rotation by D degrees, where D is not 180, okay? So it can be any degree at all now, as long as it is not 180 degrees. Are the lines L and L prime parallel? So you can, again, do this 2 ways. So you can start out with your protractor and rotate with the protractor by lining up the dot with the O here, or you can use your mirror by putting that on the dot and rotating it. So either way you go, it doesn't matter how many degrees you do as long as it's not 180. So I'm going to use my protractor. Right, and then I'm going to move it a little bit so I can use the side. If the original line is L, what is the new line going to be called?
L prime.
Thank you, L prime. Now, the main point of doing this one in this page, which I've condensed down, is this. Are your lines, and you guys all did a different degree, right? I didn't tell you what degree to do. You could have done any degree besides 180. Are anyone's lines that you drew parallel?
No.
No. Will they ever be parallel if you're not at 180 degrees?
No.
No, okay? So that's the main point of this. Are the lines L and L prime parallel? No. They will never be parallel. Unless what? Unless you use 180 degree rotation. So anytime you're asked to rotate a straight line, it will never be parallel to the original unless it's 180 degree rotation. And intuitively that makes sense, right? Like, you can't really, a line is going to go on forever. You can't really be parallel unless you are the same direction. Okay, so main points of that page. Everybody good on that? Okay. 2 more main points, and then we'll do a little bit of practice. And by little bit, I mean really little bit. And then we'll be done. Okay, page 22. Where it says lesson summary, I'm going to highlight 2 important things that many of you will recognize. You're cruising for some homework. I got some. I'll gladly give it to you. Okay. Under lesson summary, the 2 things that we really need to pinpoint, which we've done in every lesson so far, are this. The second one, rotation 2. A rotation preserves lengths of segments. We only really need a rotation preserves lengths. Does that look familiar to everybody?
Yes.
What else preserves length? Reflections and translations, right? Rotations do too. Ooh, look at what the next one says. A rotation preserves measures of angles. Does that look familiar?